students, welcome to MCQ series of Soil Physics. I think that all of you have seen my first video. Let's continue the questions. Next question, mineral particles of dash are considered for mechanical analysis. So we know what is a mechanical analysis. It is a procedure by which we will separate the soil particles into sand. We can finally know which kind of soil texture it is. In that quantitative analysis or mechanical analysis, which mineral particles we will consider. So let's see the options: less than 2 millimeter, more than 2 millimeter, less than 5 millimeter, greater than 3 millimeter. So what is the correct answer? It is option A. We will consider the mineral particles less than 2 millimeter for the because the particles less than 2 millimeter, they are actually known as soil particles. So that's why we will consider less than 2 millimeter particles. Greater than 2 millimeter, they are not. They are very big in size. They are not considered as soil. Okay, so we will not consider greater than 2 millimeter particles for the mechanical analysis. Okay. Then next question. Widely used dispersing agent used in the mechanical analysis. So this is another question from mechanical analysis. So let's see the options. So sodium chloride, sodium carbonate, sodium hexametaphosphate, sodium bisulfate. This is an important question. This is somewhat repeatedly asked question. So what is the correct option? It is the sodium hexametaphosphate. Sodium hexametaphosphate. Sodium hexametaphosphate. So this is a dispersing agent. What is a dispersing agent? It will disperse the soil particle. It will separate them. It will remove the aggregation in the soil and separate into individual particles. So we will use sodium hexametaphosphate. It is widely used. They are widely used. So sodium hexametaphosphate is the correct answer. The next, another sentence type question. Correct statement. We have to find correct statement. So let's look the sentence. Organic matter and humus are oxidized with 30% H2O2 hydrogen peroxide. Next sentence. Calcium carbonate and oxides of iron and aluminium are removed by dilute HCl. Next sentence. Soluble salts are removed by filtration with distilled water. So which in this statement, which are the correct statements? So in the mechanical analysis, organic matter and humus are oxidized with 30% H2O2. It is a correct answer, is it? So by using 30, you have to see the percentage. 30% hydrogen peroxide. It is a strong oxidizing agent, you know. So we can oxidize the organic matter and humus. Why we are oxidizing organic matter and humus? We don't want them. We have to analyze only soil, sand, silt and clay particles. So we are removing the organic matter, humus. The only way for removing organic matter and humus are oxidizing with a strong oxidizing agent. So we will use 30% H2O2. The next sentence, calcium carbonate and oxides of iron and aluminium are removed by dilute HCl. So calcium carbonate and oxides of iron and aluminium, Fe2O3, then aluminium Al2O3, like that oxides, we will remove it by using an acid. So here we use dilute HCl. So this answer is also correct. So this was also correct. This is also correct. The next, soluble salts are removed by filtration with distilled water. I don't know how many students know this. While we are dealing with salt affected soil, salt affected soil means the soil which have more soluble salts in it. So the reclamation method, or how we will improve or how we will remove the soil salt, in that one of the reclamation method was using like removing it with the water or drainage like that. So soluble, the only way for removing soluble salt is by using water. So here we will remove it by filtration with distilled water. So this sentence is also correct. So let's look the options. Only 1 and 2, 1, 3 and 4, 3, 1, 2 and 3. So this is the correct answer. So look at the sentence. You have to study this sentence. Organic matter and humus are oxidized with 30% H2O2. And by dilute HCl, we will remove calcium carbonate and oxides of iron and aluminum. And by using filtration with distilled water, we will remove soluble salt for mechanical analysis. Because these all particles we don't want that. So we are removing in the mechanical analysis. Next. According to the Stokes law, the terminal velocity of spherical particles settling under the influence of gravity in a fluid of given velocity and viscosity is option directly proportional to radius, then inversely proportional to the radius, directly proportional to square of radius, inversely proportional to square of radius. So in Stokes law, the terminal velocity is directly or inversely proportional to radius. It is asking. So the correct option is directly proportional to square of radius. V is directly proportional to r square. So it is not directly proportional to radius. It's this square you have to study. Okay, it is an important question. Stokes law. From Stokes law, this question is repeatedly asked. This can be asked because it is somewhat easy level. Okay. Terminal velocity of a spherical particle which falls under the influence of gravity is directly proportional to the square of radius. The next question, Stokes law is not applicable for particles. Options greater than sand size, greater than filter size, greater than clay size, D, all of the above. So Stokes law will not be possible, or we know that Stokes law velocity is directly proportional to r square, but it is not applicable to which particles. So option C is B is the correct answer, greater than filter size. So the particles that have a size greater than filter, they will not follow, or it is not applicable to the Stokes law. Okay. The assumption of Stokes law. Particles must be smooth and rigid. Particles must be larger than liquid particles. Must not be affected by wall of vessel. Option D, all of the above. So assumptions of Stokes law, you have to study it. It is an important part. You can see, you can watch my video. Okay, in that I have explained about Stokes law in detail, in depth. I have described. So option D is the correct answer, all of the above. In Stokes law, particles must be smooth and rigid. It should be larger than liquid particle. It must not be affected by the wall of vessel, because if the particles is not smooth and rigid, or if the particles is less size than the liquid particles, or it is influenced by the wall of the vessel wall, its velocity will be disturbed. So it cannot, it will not be proportional to r square. That law it will not follow. So we will assume that particles must be smooth and rigid. Particles must be larger than liquid particles. Then it must not be affected by wall of vessel. Okay. Then next is a match the following type. Match the following regarding ISSS classification. ISSS classification. We have so many classification of soil particles, their size and corresponding diameter in millimeter. Okay. So this question is about ISSS classification. So let's see: coarse sand, fine sand, silt and clay. So how when a question comes like this, you can answer it within seconds. Like, we all know that clay particles will be less than 0.02 millimeter. So D will be 1. Is it? But in 1, how many options are there? 3 options. So this will not be correct. We have to do this trick in some like in exams we can try this. Okay, then next see, there are two options. Silt, it will be 3, is it? Because there are 2 options, but this technique we can't use it frequently, but let's look whether this trick we can use it. Okay, so silt, it will be 3, because next to clay it is silt, it comes silt, so this will be the silt size 0.0022 to 0.02 millimeter. Then fine sand and coarse sand. Fine will be somewhat less size, so coarse, we can see the coarse, which is a greater size here, 0.2 to 2 millimeter. So coarse sand will be this one, 0.2 to 2 millimeter. So which is the correct answer? A will be 2, B will be 4, C will be 3, and D will be 1. So this A is the correct answer. So remember this. Okay, then next question, match the following regarding USDA. So this is a USDA type classification question. We have seen ISSS classification, then next USDA. In that also you have to know the size. Okay, so clay, as usual, clay will be 1, is it? Clay, so clay will be 1, because it is less than 0.02 millimeter. So next to clay it will be silt, is it? So 0.02, it will start from 0.02, is it? So which is the option 2? This is the option. Then next to silt, it will be what will be? It will be very fine sand. So it starts from 0.05. So what is the option? 0.05 to 0.10. But actually, if you know the sequence of their size, you can find it from the options very easily. So clay will be followed by silt, then very fine sand, medium sand, coarse sand, and very coarse sand. You should know the upper and lower limit of this. Then it will be very fine. Then 0.10, it is a upper limit of very fine sand. So it will be the lower limit of fine sand. So fine sand will be 4th, 0.10 to 0.25. So option is 4. Then medium sand will be next to fine sand. So 0.25 to 0.50 millimeter, 5. Then next coarse sand 0.50 to 1 millimeter. Then option will be 6th. Then option A, like very coarse sand, it is 1 to 2 millimeter. That is the last option. So among the options, which is correct? B will be correct, is it? So just remember this one. There are some techniques for solving, but you have to, if the questions ask in a twisted way, then you have to know the correct option. The next, average particle diameter of sand. Option A, 2 to 0.05, 2 to 0.02, 2 to 0.25, 2 to 0.1 millimeter. So the correct option is 2 to 0.05. Is it? You know? 2. It is 1 to 2, it is very coarse sand, which is the particle size of very fine sand. Option 3, that is 0.05. So here you look, 2, it is the upper limit, which is a lower limit of very fine sand, 0.05. So the correct option will be 2 to 0.5 millimeter. They are asking generally about sand size. So average particle diameter of sand is 2 to 0.05 millimeter. The next, unsatisfactory physical properties developed in the presence of. Option, sand, silt, clay, sand plus silt. So this is a direct sentence from the Fundamentals of Soil Science book. So unsatisfactory physical properties are developed in the presence of silt. Option B will be the correct